So my name is Rod Clare. I work for a company called Ripple Rock. We're sponsors. There's several of us running around this week. And this little funny thing here, you may recognize as a QR code, may be important to you. Because what I'm going to talk about today, there's really two parts to it. One is convince you or show you or try to influence you that an acceptance test-driven approach is a good thing to do, and that it's actually pretty easy to do. You can't do that in an hour. So most of the second part of that is going to be in a series of blog articles, code samples, all that kind of stuff that you'll be able to get to from the links on that QR code. So if you want to wait till the slide deck comes out, that's fine. If you want to get started on it sooner, I've got them up here in a business card format. So get one of those if you want them. Shameless plug about what Ripple Rock does. This section, this module, is one of 14 modules in our Scrum Developer class. Expanded a little bit, but basics, it's in there. But this is one of the 14 things that we put in that class in the Scrum Alliance Certified Developer Program. That course was written, engineered, designed around this one user story. As a .NET developer on a Scrum team, I want to effectively write code that is correct and delivers the right required business value. To me, acceptance test-driven development is about that delivery of the right business value. Okay? So before that, let me tell you a little story. And I'll tie this in later. But I'm doing flight training. I'm learning to become a private pilot. And I'm at this stage where my primary instructor is having me fly with other instructors in a mock practical exam exercise. So I go to the airport and meet up with an instructor I've never flown with before and try to impress them that I know, that I can do the stuff that the FAA examiner is going to have me do, right? So I was doing this a few weeks ago, 3 weeks ago about, and, this gal's late. We're getting started late. I know it's going to get dark and that's going to make it harder. And I'm a little bit nervous, And I get on with air traffic control and they tell me that the runway I'm supposed to use, I'm flying out of Renton, where they make the 737s, is runway 34. In other words, taking off to the north. Okay? Well, as we're pulling out and I'm checking the systems and we're talking over a little bit about what we're going to do, I see a small plane head to the north. In other words, like they're going to take off to the south. And then I see a couple of other turboprop planes, much bigger than I'm in, come in and land from the north to the south, right? Yet air traffic control has told me to taxi to runway 34, okay? So I get out here and I say, okay, I'm going to go. And I say, I'm clearing left, I'm going to turn left, and I turn left. In Renton, that's going to runway 16. That's the wrong way, right? And what happened next was air traffic control coming back on the radio saying, 90730 Victor, I said runway 34. I said, oh, you sure did, Embarrassing thing. We're first out of the block and trying to impress this instructor, and I screwed up, right? What happened there? Right? And we'll talk about that more and tell you how that ties into the points I want to make in a bit. If you think about what the big risks are in software development for an enterprise or big applications used by enterprises, you're going to find that there's a lot of problems. So you might say that it's a minefield with poisonous snakes and man-eating tigers. And it's very dangerous. A lot of things could go wrong. A lot of problems could come up. A lot of these are, and the three big ones I see are building the wrong thing. This is not delivering the business value. Being late to the party. We're late. We lied to our customers. It didn't get there on time. Somebody beat us to the punch. If it's an IT environment, we didn't get that cost savings, or we didn't enable that business process fast enough. Lots of, symptoms of being late to the party. And of course, there's the never-ending, it seems like, quality and performance issues. Okay, your bugs go in here, performance problems go in here. Okay, how do we get there? Building the wrong thing? A lot of it's communications. Stakeholders to the product owner to the team member to team member. All of these communications trade-offs or exchanges have the potential for having a really, really big impact on delivering accurate business value. And then the world changes. Maybe you're trying to build something that's no longer needed. Or another competitor has come out with something that's even neater than what you planned. You're in trouble. Okay? Building the wrong thing. Being late to the party, the list is actually bigger here. Requirements analysis takes too long. Nobody here has had that problem, have they? Oh, didn't think so. Development takes too long. Been there, done that. Testing takes too long. Oops. Too many features are built. Have you ever just built too much and that caused you to be late? Poor code quality. Doesn't run. Runs too slow. Doesn't do the right thing. The code base is viscous. In other words, it's too hard to put something else in. It takes too long. It doesn't move easily. This usually is resulting from the solution being too complex to put new stuff in, and obviously building the wrong thing will also make you late to the party. Okay? And then there's all these quality and performance issues. Bugs. Lots of bugs. Which ones do we pay attention to? Which ones do we fix? Have we found enough? It's been statistically proven that the more bugs you find, the more bugs there are to find. Oops. It can be a real problem. User interface problems. And I'm not just talking about it's ugly. I can't figure out how to use it. It doesn't work well. I can't navigate. I need this bit of information over here on this other screen, and that's not provided for me. Or the scenarios just take too long. Right? I was at a insurance company a few years ago, and they need to do this import and this processing and blah, blah, blah. And it would just take an hour just to get through this process. There's got to be a better way. Okay? The application is just too complex, is another one of these fundamental quality problems. So our problem in this space, in trying to figure out how to do these things better, how to avoid these problems, is investigating how can we make communication more clear without doing too much upfront planning. I'm an Agilist. I'm a Scrum trainer. Okay? Upfront planning rots. It's just going to sit there on the shelf and go bad. And we're doing this upfront planning at a time when we know the least about our application. Not saying we shouldn't do any, but we can do too much and it'll be bad. How do we guard against the certainty that the world will change? My crystal ball is broken. I don't know about yours, but mine hasn't worked for years. So there's very, very little we can do to prevent the world from changing or foresee the changes that are going to happen, but the code needs to be adaptable to those changes. How can we shorten the time required for analysis, development, testing? How can we make it so that we get there quicker? We deliver that business value this morning. The keynote this morning, speaker was talking about how long does it take for you to get that feature through the system and deliver it so somebody can use it? How can we narrow the scope of things being developed, the slide says effectively, in the right way? if you follow my reasoning that a lot of times we build too much stuff, that means we probably need to build less and deliver it faster. So how do we do that effectively? How do we decide what to build now, package it up and ship it, and then build something else? Okay? That's the problem I'm talking about. And then from Lean, the principle is build quality in. How do we build quality in so that we get the quality that we need so that we have a flexible application, a system that we can add things to relatively quickly? How? I think there's a lot of things that go into this. I personally believe that at the small team level, we've heard a lot about bigger team stuff this week, but at the small team level, Scrum is a really good place to start. It's iterative, it's incremental, it's team-based. I've got clients, enterprise clients, telling me that they're helping the retention of technical workers through the implementation of small team Scrum. They're keeping their people on the job. And Scrum is an empirical inspect and adapt system. So it's one that allows the system, in fact, insists that the system change to find a better way to do things, to make things work better tomorrow than they do today. Secondly, I believe a dedication to quality and learning about quality and improving quality is a very, very important thing for any team, any enterprise to make. Quality can't be a variable in the project. And we used to talk about the things that can vary in a project, just the old, time, money, features thing. Well, one of those things you can't change should be quality. We may slip the feature set, but what we do deliver needs to be great. How we do that, a lot of times, is called XP practices. So here I'm talking about unit test-driven development. I'm talking about, we can call it pair programming, but really the point there is peer review or somebody else looking at our code before we check it in and go. All those practices that are help deliver better code. Okay, and I believe if we add to those two things, those two general approaches, an approach of acceptance test-driven development, we're going to be better off, and we're going to be able to deliver the right business value. So here's where my story comes back in. As a student pilot, one of the hardest things to learn, to get used to doing, I should say, is actually talking on the radio and talking to ATC. Okay? And so you start it up, you listen to your instructor for a couple of lessons, and then they say, okay, now you're going to talk on the radio today, you're going to do this today. And so you've got what I have is a little board I strap to my leg, and I've got my pen, and I've got a notepad I'm ready to write down, because you are expected to read back the instructions that they give you. Okay? So they may tell you a little bit about the weather. They're going to tell you which way to go. They're going to tell you which airplanes you might be following. They're going to tell you what direction to go after you get off the runway, and then how you're going to exit the pattern. Okay? So there's a lot of stuff that they're going to tell you, and you're going to read that back. So this is important stuff. Especially where I fly. I mean, that's where they build the 737s, and every day there's 737s taking off out of there. And I'm just a little tiny Cessna, right? I don't want anywhere close to them big guys, right? They'll flip you over in a heartbeat. I don't want to do that. That's not a good thing. So you listen, you read back, and then they teach you to make sure you understand what it is that they said. Now, this is less of a problem in that domain because there's a lot of training that goes on, and there's a language that's been developed over the years for pilots and ATC to talk to each other. Okay? So if I, as a pilot, can't do what they ask me to do because it's not safe or it's just not the right thing to do, or I just don't understand, then before I do anything, I ask them to, clarify that, or, I'm sorry, I'm unable to do that. And then we continue the conversation before we do anything, okay? As a software development team, our requirements come from lots of different places. How do we get the feedback on that understanding from those instructions from our ATC? How do we verify, one, that we heard it correctly, that we know what it means, and we understand what they want us to do? In a big organization, they probably spent significant time preparing a presentation, a document, all sorts of different ways to give us those requirements. And more often than not, it's like, okay, here, build this, right? Here you go. Take off. Go build this. Acceptance test-driven development is about understanding and stating back those requirements in a way that's useful, okay? So you might say, well, we do that acceptance testing thing now. Well, maybe. Most folks think about, when they think about acceptance testing, let me say it correctly, what they're talking about is the series of tests that are run at the end of a project to make sure that it's ready to ship. That is not what I'm talking about. I wish in the industry we had a better term that was not as, confusing as this term, but this is the one we have. This is the one we're stuck with. What I'm talking about is automated tests written and failing before the code, and I put is complete. When I was sitting back watching the previous presentation, I put those parentheses around there. I would really like them done before we even start coding, but that's often not possible, just in the way teams work. But definitely before that sprint is done or that feature is delivered, okay? Because I want that to be, look, here's the example of what I mean, and we'll get more into that in a second. The automated tests build on specific examples of the expected behavior. Okay? One of the really simple examples I'm going to show you is a temperature converter from Celsius to Fahrenheit. Well, that is really, really simple, but all it is to show you what I'm talking about. And then the automated tests are failing in plain sight up until the point that they don't fail anymore. They can be used as one of the metrics, one of the information radiators that the team uses to communicate with the community, with the stakeholders, about where we're at and how we're doing. Okay? Now, like I said before, these requirements come from lots of different places. The stakeholders often have little practical knowledge of how software is done. And oftentimes, especially to the business, it's just done at a reasonable cost, right? Just done at a reasonable cost. And then, of course, the change monster comes in. The world's going to change. What I'm talking about is creating feedback loops for requirements. How can we do that? Well, if we assume we know, we could write the code and we could depend on the Scrum feedback systems to check our understanding. Yeah, we could do that, and eventually it would catch us, right? So maybe in the sprint demo, they'd say, again, I've heard this before, I hope never to hear it again, what makes you think that was what I wanted? Well, okay, we spent 4 weeks getting to the wrong thing. Okay, Scrum did catch it. Maybe it's a little late. Or assume we know and ask a few questions to validate our assumption. Well, did you mean this? And poke at the product owner, poke at the person that gave us the document. Is this what you meant? Okay. Or, and I've actually seen teams do this, have the developers write another doc restating in their terms what the spec was requesting. Oh my goodness, talk about a waste of time. I mean, we're just saying the same thing in different words, and it's busy work in my book. Or we could create some examples of the expected result and validate them with the source of the requirements, with the person giving us requirements, or the team giving us requirements. So here's my example, my really, really simple example. So we need a module to convert Celsius to Fahrenheit, okay? So we know a couple of things. We may not know what the algorithm is. We probably know it's a straight line. We don't know what the angle is of that, graph. But we know there's an offset too. So it may be a complicated little thing. So we could just do a table. We say, well, we're going to go Celsius to Fahrenheit. And given a Celsius number of 0, when we convert it to Fahrenheit, we're going to come back with 32. We know that, right? 100 to 12. We know that, right? Okay? What if we could code that and have that return this worked, this didn't work, or this blew up? That'd be a good thing, okay? Obviously what I'm talking about, or maybe not so obvious, anybody heard of fitness? This kind of testing we're talking about? Now let me make one thing perfectly clear. I'm not necessarily saying that you should use this tool. What I'm really talking about is the approach, is how you get from here to there, okay? I realized just now that I forgot to start some stuff up, so I'm going to step over here and make my computer do some stuff. I have this giant virtual machine that I have to use. For some reason, I forgot to start it. Uh-oh. And it went all the way back to the beginning. No, I didn't. All right. Being the trainer I am, I can't do anything without my flipper. And when it doesn't work, it's very frustrating. Okay, fine. We're not going to use it. So, a little history. Ward was here the other day. This all started with FIT, a Framework for Integrated Testing, innovated by Ward Cunningham. It was written on Java for Java programmers. Okay. Then came Fitness, written by Bob Martin and his associates at ThoughtWorks, and it's a wiki-based system. Again, wiki is invented by Ward Cunningham, that run the fit tests in a wiki-based system. Then came a lot of other fit implementations, including one for .NET. Right? The problem was, or one of the problems were, all these different implementations were different. Everybody wanted to do their port just a little bit better, and every UI, not UI, but every API was slightly different. I spent like 4 hours trying to figure out how to make the .NET Fit engine work with fit and fitness, and you can't. You have to use the other instructions. Okay, so fast forward a few years later, Martin and his cohorts added another testing processing system to the fitness wiki itself, and it's called SLIM, or the Simple List Invocation Method. It's an alternative to FIT. You can still use FIT. And it's built into the fitness wiki. Architecturally, it's better because SLIM keeps the HTML processing and the comparisons and the results inside of fitness. When you run fit with fitness, fitness calls out to the fitness server and does a bunch of stuff and then sends it back. When you use SLIM, it's all within the system itself, unless it goes out to a port of itself, of course. SLIM is very slam. I'm sure they were trying to make a very big joke here, and it turned out to be a very small joke. It's easy to port to other programming languages because that API that's in fitness now is very clean and it's very easy to do. Okay? Here's an example. And this is right off the fitness website. You can see it. They don't actually have the written instructions like I wrote out, but you might get requirements like this. And this is a simple, silly little example. Can we go get some milk, or should we go to the store to buy milk, right? And we can pay for it with cash, or we can pay for it with a credit card, and it should take into account whether or not we really need any or not, whether we have any in the refrigerator, okay? So we could write a table, and this is actually a decision table, one of several kinds of systems that I'll show you in a second, that says, in a class called Should I Buy Milk, I'm going to have a property that is cash and wallet, and another property that says, is the credit card good? And another property that says, how much milk is in the refrigerator? And then a method that says, go to the store. Okay? And with those columns, with those parameters for this system, I can set the various testing conditions, or scenarios, if you will, that are specified in the table. Okay? So then we do a little work, and we'll talk about that little work in a bit, but we'll do a tiny little work to hook the fitness system up to the system under test, and then go run the test. Okay? Now, this is the PowerPoint IDE. This is not really fitness, but this is the way it sort of looks. And I'll show you this thing really in fitness in a minute. But in this example, the green on Should I Buy Milk says, oh, I found a class by that name that has these particular features. I found a property, and a property, and a property, and a method. Okay? And then it says, for each of these scenarios, I got what you expected. They're colored green. Okay? Now, obviously, the team has done some work on the Should I Buy Milk algorithm, because all of our tests have passed at this point. Here's how this process works. The requirements by example are these tables that get built. These record a business process, a conversation, the decisions, the result. How do we want this to work? Keep in mind that the two I've shown you so far, the temperature conversion and the Should I Buy Milk, are very, very simple. We can do much, much more complicated things. If I did one of those here, I'd really lose you. After we have those tables, then this little simple piece of hookup code gets written. Okay? All this does is create a stub, a place for us to hook up to the real system that's going to be called and do the work. This code is trivial. Okay? I've taken testers who were trained as coders and taught them how to do this. Several different kinds of tables, several different kinds of coding problems, and get the tests failing in less than a day. And in fact, we use this temperature converter problem in the class, and we do it in about 2 hours. Okay, so it's not that big of a deal. I mean, teach them and they do it. Okay, it calls then, in turn, the system under development. Okay, and then the system returns the results in the tables. The tables then are colored when they come back to us in the screen: red, green, yellow, gray. Okay, so green is, we saw that. That's good. That's a good thing. Red, it's not what we expected. And when it does return red, it gives you the expected value that you put in the table, or the team put in the table, and what it really returned. So you know what the answer was that it got, even if it was wrong. Okay? Yellow means blowed up, boss. Something didn't work. Okay? And gray is a special case where you didn't enter the answer in the table. And so you're saying, gee, I don't know what this should be, but this is what I got back. And so it'll code that gray. Color that gray. Okay? Number of different kinds of tables, and it's an open system. You can build your own. decision table is we were just looking at. A query table, again, here we're talking about database stuff. You can tell it what you expect the database to return or whatever kind of a system it is, or not, right? You can leave it empty, it'll come back gray, it'll tell you what it got. Script table, a series of actions. A scenario table, a table can be called from other tables. Table, that's kind of a silly name for it, but it is exactly what it means. What it says there, whatever you want it to be. And then an import table that'll search and pull other code in for you. So let me show you a couple here now while I've got plenty of time. I'm talking fast enough that we're going to be okay, I believe. So here is a fitness instance that I've created on my laptop for this talk. Okay, so again, there's the code if you want it. Okay, and here's, in fact, I'm going to go over here. Where did I put my examples? Here they are. So here's another example. This is just another example of a decision table. Okay, and this is one right off the fitness website where the code's all Java, and I've rewritten the back-end code to make this run in .NET. But anyway, they'll all be in this sample if and when you decide to download this and take a look at this. Let me just run all of these so you can see them all run and see them all return the state of where they're at, whether they're good, bad, or indifferent. So I think probably the most interesting one here is the script table example. The scenario that they're working on is actually building like a TV guide for an online system. And the idea is it actually walks through a series of steps that a user would execute in the system and checks and verifies that the system does the right thing, returns the right response. Okay, so they're testing the UI without having the UI. They've separated the interface from what the interface does. What a good idea. Okay? All right. The timeline is pretty simple. Can be simple, can be complicated, but conceptually it's simple. Product owner talks about the stories and comes up with some examples of what these tests might include. Then the developers and testers during the sprint add more detail in planning and the actual execution of the sprint. And the developers work only to make these acceptance tests pass. Remember I talked a few minutes ago about narrowing the scope of what gets delivered? Have you ever seen code show up in a program, show up in an application, and you're trying to track that down? Where did that come from? What does this do? And you send a few emails out to the team, and finally you track it down, and you go to this developer's desk, and yeah, I just thought this would be cool to have. It's a developer good idea. That's what I call it anyway. Had nothing to do with anything that we wanted to do, but they spent X amount of time on it. It's in the system, and you're probably stuck with it. Probably tough to get it out of there. If you narrow the focus of the team to only passing acceptance tests, that's all you're going to get. And that's a good thing. When they run out of work to do, you write some more acceptance tests, or you have more queued up ready for them to write the code to make them pass. Are we going to find more all the time? Sure, we are. We're going to add functionality, but all that analysis is done will be done in the context of where the system is right now. So it's the next most important thing that we need to do. So if the first scenario was really, really limited, right? You know, you could take our go buy milk sample as an example. You know, maybe we can, I don't know, have grandma go get milk. You know, well, maybe it needs to be more robust. Okay? Have Amazon Fresh. I live here in the area. Amazon Fresh bring us the milk. You know, we can do that. Okay? So maybe that's the next most important thing we need to do, and that's what we go work on. Okay? So the question that I get is, and I teach this to .NET developers all the time, and they say, well, my buddy Doug Shimp and I just got off doing 3 classes of my Scrum for Teams, which is a 5-day version of the 3-day class. When we taught this stuff, and we had these guys from Microsoft Premier Developer Support actually learn how to use this, and they didn't want to put Java on their boxes. Anyway, it was a problem. They said, well, how does this fit? I can't see how this fits in my world. Okay? Well, it's not that tough. Let me show you something else now. So while this comes up, well, let me go back to that other screen because I can explain the story over there just as well. Well, where'd he go? There it is. So here's Professor Funk. Professor Funk, he is a great hardware guru. But Professor Funk and his team are not very good software developers. Seems like every time they put something else in, it's just going to break. They're just having lots of problems with their code, right? So he's trying to figure out how to make this, make this problem go away. And so he figures out, or somebody helps him understand, that an acceptance test-driven approach would help them out. Okay? Here's the first problem that they wanted to deal with. Okay, so here's an example. Whether or not you use fitness to document your requirements, that's another question. Okay, not necessarily saying you have to do that, but it's a very easy and convenient place to do that. Okay, so this is an ambient temperature control system in the FunkMaster 2012, which is the new laptop that Professor Funk has invented, and what he wants to do is 2 things. One is automatically set the fan speed based on the ambient Kelvin temperature. Hey, they got it, this piece of hardware that only talks in Kelvin, right? And he wants to bump the temperature or the speed up when he's got a bad humidity problem, right? So he doesn't want condensation in there, right? So we've written these tests in these examples. And now we can run our suite. We can see what happens. Uh-oh. Now, see, Rod, you should have tried this before. Typical Microsoft demo, right? Test not run. Why did the test not run, Rod? Did you move it? What did you do? That other one ran, didn't it? Sure did. Why didn't this one run? Let me try it from over here. Well, okay, so now I'm going to be very embarrassed and red in the face because they're not going to run. But the bottom line is, oh, maybe this is my problem over here. Something's asking for a password. We got TFS running because the bottom line is it's really neat to see those tests run in that graphical interface. It's really fun. The team really, can be proud of that and see those turn green. But in any real world scenario, we've got lots of teams and lots of complicated code and lots of things that need to be done. Those tests need to run in your regular automated build process. So it's not original work. I didn't write this code. I went out and found this code and pieced together the parts and pieces to make this system actually run the tests inside the build system in TFS. Simply, rather than get in too much in the details, I wonder if I can make that any bigger. It's kind of hard to read. But basically what it does is there's a small application that's probably, 40, 50 lines of code that I found out on the net. Somebody else wrote it. And I'll give credit to that person when I actually write the article that I'll put up on the blog, because they deserve the credit. And an XSLT that takes the output from the fitness and pushes it through this transform and puts it into MS test structure, schema, so that when you run these tests in the automated system, and this is what you do is you wrap it in a generic test, you actually get these tests to run within the build system. Okay, so this is actually one of the generic tests that I wrote. So the gen runner actually just goes and gets this output from the run settings. Use the right mouse here. This is actually a command line call to that fitness server. So the machine name, what port it's on, what project and what suite of tests you want to run, and it uses this gen runner and then actually runs those tests. So let me see if my TFS is up and awake and happy now. Let me start Visual Studio over here because that's just the easiest way to see these tests run. So I've created a build, click on the right thing here, to run the FunkMaster 2012 builds. Let me edit this so you can see that this is actually pretty simple too. Get over here in the right place. Edit build definition. So what is it we're going to do? We're going to run a continuous integration. This is how you set up a build. What are you going to build? Okay, we're going to build what we put in source control. We're going to drop it back, to this server. And here's where the tough part, it's not really tough, but you have to tell it to run a generic test. And when you set one of these automatically up, or when you set one of these up to run your unit tests or other kind of tests that are in your regular Visual Studio system, you're just looking for star test star.dll. Okay, well in this case, we're actually looking for that generic test, so it's star.generic test. Okay, that's really all the difference that there is. Okay, so what I can do now, let me close this, and I'm going to over here to go to the queued. I have confidence that this one's going to run because it's actually on the server, not on my box. So it's chunking away. It's actually running all the tests, not only the generic test, but the fitness test, but it's also running the unit test that the team might have run to write this code for this ambient temperature control system for the Funkmaster M2012. Okay? So while we wait for that to run, where did I confuse you? What questions do you have? Yes, sir, right there.
Can you open up and show a little bit of how you actually implemented that test at the actual code level?
Sure, sure. So he wants me to show him the actual test. And I imagine you're talking about the fixture code, the hookup from the fitness table to the system under test. Okay, we'll do that in a second. Okay, so there's one. What else we got? Any more? Okay, well, while that runs, oh, hey, some passed and some failed. Imagine that. You ever have that happen? Mm-hmm. So we'll go look, and we'll take a look in here, and here's our test results. I don't know if you can read this or not, but the ambient temperature control system had 0 right, 0 wrong, and 50 ignores and 5 exceptions. Yet the environmental control software system, 6 right, 2 wrong, and 1 ignore and no exceptions. So those are actually fitness tests running within the TFS build system. Okay?
Do you get anything when you show test details there?
Down here? More of the same, and you could definitely augment the XSLT. Well, you're not going to get any more information back than what fitness gives you, obviously. But you might be able to augment that code to give you a little bit more information or a little more details. The interesting thing that I found out when I was trying to put this together is that there's this idea of a suite of tests, that you have multiple child pages that have other tests in them, and you can run them at the suite level, you can run them at the test page level. And the program and the transform that I found, it doesn't actually run at the suite level. I had to do them at the test page level. But again, I think that's a minor problem, and that's something that we could augment going forward to make it be so that it would run the suite from the suite level. All right, so let me go back over here, get this on this screen where you can see it. So let's say, I think they're down here. No, this is a unit test. Well, this is a unit test. Oh. That's about all it takes. This is a pretty simple table, obviously. But what this is saying is, go find this namespace, and I could go into why that namespace has the underscores in it, but it really is so that fitness understands that that's a file rather than a page in itself. And we're going to test this class, automatic fan speed Kelvin, and see here's the temperature and the speed. These are the things that you would find in that table, and I'll pull up that table in a minute and show you that. And so you can see where I commented out return 99. That was my first failing test. Okay? And then later, when the auto fan speed system was ready, I just newed up one and called it with my temperature. Okay? So let me show you that test page. Well, is that it? Yeah, that's it right there. And again, I don't know why they're not running. They're running the server. But all that is there's the temperature. It's looking for a method or a class called automatic fan speed Kelvin. It's got a property named temperature, and it's got a method named speed. And we do an input of 275. We expect a speed of 2750, so on and so forth. Okay? Questions? So again, more about this, how to do it, how to make it work. Even help with problems that you might have through those links that are on that QR code. But there's the first article, just the basics of how to set up .NET testing with Slim and Fitness. Yes, sir.
Have you tried this with applications that do database?
The problem you run into there is if you're not really testing the database, those tests are going to run really, really slow. Obviously, if you're really testing the database, then you have to connect to the database. But rather than run a test with a test connected to a database, I would mock that database out so the test will run fast. But the answer is yes, you can do that. And that's what that query table type is about being able to test the results of a stored proc or some other system, writing data and making sure they got put away correctly.
But if the goal is to drive these during your build, does that all has to be then available to your build environment?
Right, and that's why I say if that's really not what you're testing, if you're not really testing the database, then I'd avoid that if I can, because it's just going to slow those things down. But yes, you can do that. I'm sure there's a lot of folks out there. And maybe you set some tests up that will only run once a week, right? Or you run them every other night, not every night. Something like that, to control that time that it takes.
The last thing I noticed, this is all running in Visual Studio 2010?
Yeah.
Is it using any specific feature of 2010? Like I saw you reference that generic testing.
That's the only thing I can think of. And I can't imagine they're not going to keep, roll that forward in, pretty much the same way it is. It's used by a lot of people for a lot of different things. Okay? Yes, sir.
Where did you get the XSLT to plug in there?
I'll write an article. That'll be about the next article that comes out. And if you want to just drop me a note, I'll send you a link. I can't tell you off the top of my head. But yeah. And I'll put them in these zip files when I publish them up. I don't have any up there yet for download, but I will shortly. Over the weekend, I'll do that. Okay? All right, now I'm going to try to make these tests run. If you want to hang around, because I know they will run. I just have to figure out why they're not running.